So we have Damian here. He is a consultant CTO, architect and trainer from Brisbane, and he's here today to tell us the most important thing you need to know about microservices. So take it away.
Awesome.
Thanks, Damian.
Thank you. There we go. Thank you so much, April. This is amazing. How good are conferences? This is cool. Thank you all for coming. So my name's Damian. As April said, I'm from Brisbane. Damian M on Twitter. And I'm here to talk about the most important thing you need to know about microservices, which is somewhat clickbaity, but we'll get there. For those who can't see well, this photo I took on Thursday. We're sitting at the docks on Freo, watching container ships come in, and I thought that's a perfect picture for this talk, so I added that one in. Firstly, I'd like to thank all of the sponsors of this event. Obviously, without sponsors, events can't go ahead. And also all of the crew and volunteers for this conference. It's been, as a speaker, it's been amazing so far, and I hope you're all having a really cool day. Cool. Start my timer. All right, so who am I? I'm a consultant CTO. Essentially, I've been a consultant for a long time, and I've been a CTO of a few different companies. So a few of these you might have heard of. Redify, which is now Telstra Purple, I worked there for a long time. Was an early person at Octopus Deploy. I've done a couple of very bad hardware and software startups that I don't talk about too much at parties. And as a result of that, I'm now a freelance kind of consultant CTO is what I call it. So essentially, I found a little happy spot where I work with smaller businesses and bring, you can see from here in the photo, I am middle-aged white guy in tech. I've got 23 years experience of seeing the good and the bad, and I sort of work with smaller companies to help them avoid those sorts of problems. And yeah, that's what I do. And also, I'm going to talk about this a little bit at the end. I'm a trainer at a company called Stack Mechanics, which I'll talk a little bit about later on, essentially to help people, in larger groups to avoid some of these mistakes. Rambling. This is the first time back for a while. All right, so the agenda today. I'm going to give you a little bit of background and historical context about microservices. I'm a big believer that in understanding the history of something, you can kind of understand what problem it's solving and why we might want to do that. I'm going to talk about some of the mistakes that I see and the impact of those mistakes that I've seen, and then some of the principles and techniques and thinking and design principles to not make those mistakes. And I'm going to get into some of the sort of tech stack details, but essentially it's more around conceptual stuff. So, some background. For a lot of years with Redify and also my solo consulting stuff, we'd often kind of go into the burning building, rescue stuff. And often in those situations, you get to a point where people are like, well, we need guarantees that this is going to work. And you go, we can't guarantee anything because everything's on fire. So what we started to do, these sorts of approaches over the last 10, 12, 13 years is you can't make big promises. So what we would do is ship something really small really quickly, and then ship something else really small really quickly to kind of get some runs on the board and prove things. These patterns that we sort of took out of that eventually became, called microservices. And lots of tooling in the sort of infrastructure, like Octopus Deploy and Serilog, and some of the sort of tools that as .NET developers, I'm assuming, are most people here .NET developers? About half? Okay, cool. Tools came out of that space where we're just like getting in as a consultancy and having to solve problems really, really quickly. So that's part of the background of why I like microservices. The other part of this talk is we are in a very hype-driven industry. You would probably know this, yes? And it's very cyclic as well. And sort of part of my advantage of being, in tech for 20-something years is you start to see the same bad ideas recycle with new names. And I'm going to see a couple of nods here go, yes. And sometimes those ideas get renamed. It was like, this is a great new thing, and I kind of, put on my grumpy old man pants and like, no, we've done that, and what happens is, everyone kind of jumps on these bandwagons and they write blog posts because everyone wants to kind of get noticed for stuff. And you got blog posts like, oh, this is an amazing thing, and people want to get on Hacker News, and companies wanted to attract talent. We'll do posts about how they did things. My favorite is Uber Engineering's blog, because every couple of years they change everything and write a blog post about it. 1 year it was like, we've moved away from Postgres to MySQL because it's faster. And then 2 years later, they just finished that migration, go, lol, no, that was a bad idea, we're going back again. And that's kind of fine for Uber because they're massive and they've got billions of dollars of venture capital funding. And most of us aren't Uber. We can't afford to make those mistakes and rebuild our database every 2 years. So yeah, part of the problem is very hype driven. Everyone wants to be kind of in on the latest thing, and we end up with this. So for anyone who can't see this well, this is a sort of well-known meme of a dog sitting drinking a coffee with flames all around him, saying, this is fine. And I'm going to repeat this a few times, so if you sort of can't see the slides and you hear me say this is fine, just picture the dog in the burning building thinking that everything's all good. So yeah, we build these things and it ends up just in a disaster. And as much as I actually quite enjoy as a consultant, going to the burning building and picking stuff up. It's a sick satisfaction I get from it. It would be great for the entire industry if we didn't do it, if we didn't set stuff on fire in the first place. So my goal today is kind of understand why we might do microservices and some of the thinking we need to do so that we can stop setting things on fire. All right, so history. Again, this is one of these, everything old is new again. Every idea in software is built on something before it, solving a problem before it. So I want to sort of talk a little bit about my version of the history of microservices. And so, again, there's some assumptions and opinions here, but I have cross-checked this with a few people. So it started with something called SOA, Service-Oriented Architecture. A few knowing nods. Who was around when SOA was a thing? Yeah? Good number. So SOA was a cool idea. And the idea was that, and this is sort of in the early 2000s, in the sort of .NET space, it was like .NET 1, SOAP was the great new thing, and web services. A few people go, oh no, I remember SOAP. And the idea was good. It was, you had loosely coupled services that autonomously managed a business process. And you could then build applications based on those services. So, you might have service A and service B and service C and service D, and then application A goes, well, I would like that thing and that thing and that thing, and the applications that sit on top of the services, and big companies could build out services and everything would be great. It wasn't. Because what we'd end up with is something that looked a little bit more like this, where every service or every application talks to every service, and every service talks to every other service, and they were usually all sitting on top of a shared database. And it was just a mess. And a lot of this was because we got the modeling wrong. It was meant to be an autonomous business process managed by a service, but typically it wasn't. The modeling got wrong, and it wasn't self-contained at all. It wasn't autonomous, and everything, looked like this. And from the laughs, I know a few of you have worked on this sort of fun. I worked on one where you had a data manager service where they'd sort of re-implemented a relational database on top of a relational database over SOAP. And it looked a lot like this, and every service needed to start in the right order, or the application would not work. So then we had a service manager run a service or something that made sure that things got started in the right way. And it was bad. So the software industry came up with a great solution to this. Does anyone remember what that was? It was the enterprise service bus, which was, vendors came in, we'll solve these problems. And enterprise service buses, for who don't remember, they were expensive. They were generally sold on golf courses to CIOs and then just put in place. This is very triggering for you, I can tell you. So and again, the idea of an enterprise service bus wasn't a bad one. So the idea is that we had our services, and rather than them all talking to each other, they would talk to this enterprise service bus, and the applications would talk to the enterprise service bus, and the enterprise service bus would figure out where to route requests and how to translate them and whatever else. And all of this logic was in the hands of business analysts and enterprise architects, and the idea is that the developers could just cut code on these services. The problem was we ended up with so much logic in this service bus that it became very fragile, because essentially you're doing software development in a browser window. For BizTalk, was a browser window that looked a lot like SharePoint. Writing code in there without validation, without testing things. And so what happened was it became very fragile, so nobody wanted to touch the logic in the enterprise service bus. So, as agile developers, what did we do? We routed around it. This is fine. So, what came next? And this is my memory of history, and everyone's memory of history is a little bit, along came REST. So essentially, there was a guy named Jim Weber who worked at a company called ThoughtWorks. I'm sure everyone here has heard of ThoughtWorks? Yep. So a guy named Jim Weber, the story goes, he was working on some horrible rescue project, sitting in a data center, trying to fix BizTalk at 1 in the morning, and just went, enough of this is terrible. So he and a couple of colleagues started to just go, we're not going to put something in BizTalk, we're just going to build a service over here in Tomcat and just put an HTTP API on it, and we can call that, and just kind of, separate some of those functionality out. And ended up writing a book on REST called REST in Practice, I think, a really good book on REST. And sort of, it was around the time that REST sort of became popular, and ThoughtWorks started to do a lot of stuff around these sort of HTTP-based services that were simple, built on, I think, Jetty, and using REST and hypertext. Around the time I first heard the term microservices, it was sort of emanating from a company called SoundCloud. I'm sure a lot of you have heard of SoundCloud. They did audio streaming and downloading stuff. So SoundCloud had an application. It was getting big. They were getting popular, and it was very monolithic, very hard to maintain. Wasn't scaling well. So they hired a bunch of people actually from ThoughtWorks in Berlin, and one of the leaders there was a guy named Phil Calcado. And so what Phil started to do with his team was break stuff off. So they had this big monolithic Rails app, and they'd break some stuff off, build a simple HTTP service over it, and a few other people in that space were doing similar things, and eventually they became sort of known as microservices. So the historical sort of timeline here is you can kind of go from SOA to bad SOA to HTTP to REST to microservices. And then a guy named Sam Newman, who was also at ThoughtWorks, wrote a book on it, which I'm sure a lot of people have seen, and it kind of just exploded from there. But of course we ended up back here, where we had lots of services, a couple of applications, but all the services talking to each other. A lot of people did it, again, with a shared database, and got the modeling completely wrong. And we ended up back here. This is fine. So who's worked on one of these in microservice land? Yeah, a few people, right. So that's the history. So where does it go wrong? And this is, I've spent a lot of time digging out of this and thinking about it. And the first place it goes wrong is people get way too caught up in the tech. Yeah, and this is a fairly common pattern in our industry. You've got a problem to solve. You start a project, everyone's excited. You still don't really know what the business requirements are, because that's someone else's job as a developer. And so we're sitting here, we don't know what to do. I know we'll build our own framework, and we'll build our own ORM, and we'll build our whatever. And so in more recent years, people then get really hung up on the infrastructure. It's like, right, we need to build a thing. It's like, cool. First we need to do is get Kubernetes and put Kafka and Postgres in Kubernetes and just get way hung up on the infrastructure before shipping a line of code. And essentially you start solving problems that you don't have yet. You don't know you're going to have yet. Tools are great. All of those tools that I mentioned are fantastic tools and fantastic infrastructure, but if you start layering on stuff before you've even understand the problem, you probably need to stop. And this is kind of agile one-on-one, right? Like we don't do big design up front. A lot of people do it. Like in map, I saw one recently. There's some tool. It's like a graphing tool for sort of object graphs. And like a team that had not actually shipped this system, and the object graph of services was like, I couldn't fit it on my monitor. And they'd never actually shipped anything. They just got way hung up on stuff. And just solving problems that, they didn't have yet. So sometimes when I'm feeling snarky, I'll say to people, if you haven't shipped one thing, what makes you think you can ship 20 tomorrow? And that makes me popular. I've had this conversation like, right, we need to start this thing. It's like, first thing we need to do is choose a container orchestration platform. It's like, well, you really don't. You actually have a bunch of stuff over here, your legacy system, it's a bunch of servers, and, it's a proof of concept. Like, let's see if we can ship a small thing. And, so people are just way hung up on that. So one of the attributes I've seen of microservices architecture that have been very successful is they've evolved from something that worked. Okay, like SoundCloud example, they had a Rails app, they had traffic, they might have even been making money. Crazy. And they started with something and it was creaky, and they sort of broke a little bit out and started with something that worked. And typically those things work quite well, because here's a problem, let's take a chunk of it off. The ones that start with a blank slate and go, cool, we're going to need 30 services, typically never ship. Again, because if people have not worked with this stuff before, they don't actually know what challenges they're going to hit. So yeah, often good architecture will evolve from good working software. Or maybe it's not working well, but you've got something that works, you understand it, and you evolve from there. So often most of the successful stories I've seen have started from something that was already there. And particularly with legacy systems, I've seen a lot of... Who's worked on a failed legacy system replacement? Yeah, right. And generally they were like, here's this thing, it's old, it's clunky, we don't like it, it's buggy, it's hard to maintain. You're like, cool, what we're going to do is we're going to start again over here. And this time we're going to do it right. And you never get there, right? Like you never ship it. So whenever a new requirement comes in, a new requirement's always come in, they're like, well, that's not ready. It doesn't do X, Y, and Z, so we'll put it over here. And all of a sudden, you're chasing a target that you'll never actually hit. Yes, familiar? Yeah. Legacy system replacements that work really well is you've got an architecture that lets you sort of move something across at a time and make them talk. And go, we've got this new requirement, we'll put it over here and we'll integrate it. Because software is never done. Software is done like a lawn is mowed. You can mow the lawn, the next day you're going to need to mow it again, or the next week. So the idea that we're going to just replace a system, turn it on, turn the old one off, and we're done, is just not a realistic one. So now I get to the clickbait. Other than all of that stuff, the one thing that you need to know for successful microservices architecture is software modeling, which, gets thrown away. Modeling's hard. Like software modeling is hard. This is why we have jobs, because modeling good software is a tricky thing to do. And it's hard to do in one solution. If you file a new project in your IDE of choice, and you go, right, we need to solve this problem, it's hard, right? Like coming up with the design and the modeling is a tricky thing to do. And it's hard in one project. If you start with 20 and you need to refactor something, all of a sudden you've just, multiplied this problem. And so what people typically do is spin out all their services, 20 of them, and then realize that they've not got the modeling right. And then you sort of start routing around everything, and everything talks to everything else. And we're back to that kind of bad SOA thing. And then people bring in more infrastructure to solve the problem. Our services are talking too much. Let's bring in a service mesh or poly or something like that. So yeah, modeling. So a couple of common, really like common sort of code smells or architecture smells that I see. My favorite one is when you've got a service for an infrastructure function. Who has worked on a data service or a data manager? No? Good. So, if you've got a service that are based around sort of infrastructure things, you're probably going to be having a bit of a bad time. But the other main one that goes wrong is what gets called the entity service anti-pattern, or a service per aggregate route. Did those names just go over everyone's head, or am I? Who's read this book? Who's actually read it? Who got to the end? Yeah. It's an amazing book. It's one of the driest books you'll ever read. And one of the things about this book is, actually, who does domain-driven design? A few people? You're hesitant, you're like, I'm going to get called out in a sec. So, you've got some repositories, some services, yeah? Do you have an on-site business expert that you talk to and develop a custom vocab? Yeah, okay, cool. Excellent. You're the first one. So, domain-driven design is actually a book around software modeling, but nobody gets to that bit because it's at chapter 15. And people get through the first few chapters around services and repository pattern and blah, 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 and naming your functions really long things, and then never get to the final chapters. And Eric Evans, actually, I saw him give a talk about this book, and he went, if I had my time again, I would just change the order of the chapters, because nobody actually gets to the meaty bit. So, if you're modeling software, you might have a customer, an order, and a shopping cart, and catalog, and pricing, things like that when you're doing your modeling. And that's called an entity or an aggregate route in domain-driven design, right? So often what we see is services that look like this. And you can go and look on Microsoft Best Practice Microservices. You get something that looks a lot like this. And all of a sudden, we've got a service for every entity in our model. Yeah? Does anyone remember Javal Lowy? Early SOA said, and everyone thought this was a very outlandish thing to say, but Javal Lowy said that in a good service-oriented architecture, every class would be a service. And everyone laughed, thought this was a ridiculous thing to say. But we've kind of ended up here. Again, this is my grumpy old man showing. So what happens is, software, there's a couple of principles of good software design around loose coupling and cohesion. And so software, to collaborate within its design, needs cohesion. And if we've split it too far apart, then all of a sudden, we're talking too much over HTTP. And then you have to deal with distributed computing a lot. Because software, is cohesive, all of these things talk to each other, and if all of a sudden you're talking to each other over a network boundary, then, again, you've got all sorts of problems. And so what I see is services just are way too chatty. Has anyone kind of worked on a microservice architecture that's just way too chatty? So then you bring in more infrastructure. You bring in, Istio and sidecar services and service meshes and things like that to solve the fact that we've just split our design way too early and our boundaries are done way too early. So some of the symptoms of that, when you see it, is massive amounts of shared code. So then we go, okay, all of our services need the same classes in there. So, okay, we need a mono repo, or worse still, we have everything in one giant solution. And I've seen that like 20 microservices in one Visual Studio solution because they need so much shared code. And then you have back to the problem that we had in the early 2000s, which is you need to deploy everything in exactly the same order because you've got 4 services with the same classes, and if those classes don't match, you've got all sorts of errors. So then, everything has to be deployed at exactly the same time. So they're not autonomous anymore. When I was at Octopus Deploy, one of the things that we did at Octopus, and they still do, is pretty much everyone does a rotation on customer support, which is, if you've never done it, it's an amazing way to develop empathy for your customer. And you can make design decisions and then see the impact of that by figuring out what's hard for people to do and where they get it wrong. It's an amazing process for kind of building empathy within your team. So people would write in or email in, and they'd say, Octopus doesn't support microservices. And we're like, what do you mean? It's like, we have all of our services, each one's its own project, but we need all of the projects to be deployed at exactly the same time. Right. So what this gets snarkily called is, you don't have microservices, you have a distributed monolith, which is kind of the worst of the worst of all of those worlds. And then again, we start adding infrastructure to it. So, for those of you who got through 15 chapters of the domain-driven design book, there's a concept called a bounded context. And again, this is a book about modeling, and you start speaking to experts within the business, and you develop a shared vocabulary. And in chapter 15 of the domain-driven design book, Eric Evans says that if you start to notice that different groups of people in the business start using words differently or talking about something with a different phrase, that's a bounded context. Yeah. And you find that, if anyone sort of worked in a big organization, you might say, well, this thing is an order, but an order to somebody else is a completely different concept. Anyone felt that one? Yep. So the best example of this I've heard was from a guy named Dan North, who was also ThoughtWorks, and he gave a talk a bunch of years ago that I'm going to steal shamelessly, where he talked about going on holiday. And he has this concept of, okay, I'm going on holiday. And your view of your holiday might be a postcard or a website or a magazine article where you've got beach, white sandy beach, cocktail, umbrella, snorkeling, whatever it is. That's your, I'm going on holiday, I'm really stressed, I need to go and sit on the beach. Okay? That's your view of a holiday. But to get there, you need to do a few things. You need to put in a leave request. Okay? So then your HR department needs to think about your holiday. Now, your HR department's view of your holiday is not white sandy beaches and a cocktail with an umbrella in it. Your HR's view of your holiday is, do you have enough leave days? That kind of thing. How many hours have you accrued? You might also have to get that signed off by your manager. Your manager's view of your holiday might be, well, actually, we have this project deadline. We've got our legacy system replacement. It's due to go live next month. No, you can't go on holiday, which is exactly why you need to go on holiday. You might call a travel agent to, book you a flight and a hotel. So they're going to have a completely different set of words and different lens and different framing of your holiday. It's all the same thing, but everybody has a completely different set of terminology and way of thinking about and framing your holiday. And that's a bounded context. Yeah? So bounded context around the people involved in something and the interactions with it. Okay? So if you think about building services, you can start to use that framing around what a service is. So if you've got a bounded context, well, we look at this thing and it means this to us, that might be a really good place to start with a service. Yeah? And then what you can do is model the communication across the people in this organization and how they communicate that stuff. And that becomes then a really good shape of what your service looks like and what that sort of bounded context looks like. So, if somebody says in your organization, go do this, that's called a command. Or if somebody else sits there and they wait to be told about something, that's an event. And we can start to model then commands and events and requests within an organization. So, to put an example on that, think about a really bad restaurant. Okay? You imagine turning up to a restaurant and you sit down with your friends and a waiter comes up with a menu board with no prices on it. Just go, here are the things. And you'd say, how much is the burger? And they just run away and come back and go, that's, $12. And you go, I'll have a burger, thanks. And they go, okay, I'll just check if we have them. And they run back into the kitchen, come back and go, yes, you can have a burger. And I'm like, cool, well, I'd like the burger, thanks. And we'd also like the fish. And like, hang on. And they run back into the kitchen. A few minutes later, come back and go, no, we don't have fish. And so you're frustrated. You're like, well, can we have some pizza? And they run back in. And they go through this process of like running back in and checking if they have it for all of the food and all of the drinks for every single person at the table. And then you go, okay, got the order right, I would like that. And they go, cool, that will cost this. Well, we haven't eaten yet, but okay, here's the card. And then they walk and they stand in line behind all the other staff in one line to get to the one FPOS machine. Payment gateways are hard. And eventually they get there, process your card, and it's declined. So they come back and go, that card was declined. You're like, that's right, I've got to put money on that account. So you transfer some money over, and they go and get back in the line. And you're sitting there, at this point, you're hungry, you're grumpy, because this order still hasn't gone to the kitchen because you haven't paid for it yet. And they come back and go, yes, that was successful, and then they go into the kitchen to place your order. And then they just disappear. You don't see them again for a long time. And you realize that all the wait staff are walking into the kitchen and not coming out until they have the food. Yeah? So eventually, your waiter comes out, gives you food and you eat the meal. But at that point, you're having a bad time. It's not a great dining experience. 1 star would not do again. And this company's not going to last too long because they're going to need way too many staff. They're going to go through the staff because everyone's rude to them. And it's not going to scale, right? Has anyone been to this restaurant? It sounds pretty bad. This is how we build systems. This is how a lot of people build software. Because, coming back to this kind of sort of canonical microservice architecture that you see, it looks like this. And we've got all of these HTTP requests. Now, what's something about HTTP requests? They're synchronous. Okay? And so we build this stuff, and this is kind of how we build this restaurant. Like, I would like to do this. I will go check the pricing service. Like, literally every microservice kind of beginning article has a cart service and a pricing service. And that's like the waiter holding the board and then going to have to ask the manager how much the burger is. And it's bad. This is how we build systems. So let's think about a better restaurant. You walk in, you sit down, the staff hands you out some menus. The menus have prices on them, menus have specials on them. Because somebody sat down, when those prices change, created a menu and put it on there. You sit down and they go, actually, look, the kitchen just told me we've just run out of fish, so that one's not in there. You're like, okay, cool, that's fine, I'll order something else. And you sit there and you go, here's the order. And the staff, write the food on one slip and the drinks on another slip. And they, take one slip to the kitchen, another one to the bar, and your order's in. All easy. And then after a few minutes, bell rings at the kitchen, okay, and some staff go over to see what the bell was for. And it's like, okay, table 10, food's ready, and they bring it to your table and you sit down and eat it. And when it's time to go, you go up and you pay. I'd like to pay for table 10. Again, you might still have the FPOS problem, but it's easy, just kind of solve it. And meanwhile, you've got a restaurant manager who's sitting there kind of overseeing, like, has this table got their food on time? Is anyone waiting too long? Is everything kind of working as it is, right? That's a better restaurant because you've got, it's fewer staff and they're getting more done because they're not relying on waiting for answers all the time. They take your order into the kitchen, they say, make this, yeah? And when it's ready, someone rings a bell and they come and get it. One's a command, another one's an event, yeah? And so the way these, like it's the same activities, they're still ordering food and they're still cooking food and they're still bringing, still paying, but it's the way those activities are grouped and who's in charge of it and how the communication happens is better modeling, yeah? Does anyone go and watch businesses and just like think about the systems? Like massively into systems thinking, and you look at that and go, if that person did that job, everything would go better. Yeah, it's great people watching. I can't help myself. It's modeling, right? And so in this restaurant, the staff know when something's run out. They've got the prices of stuff. The kitchen knows when to make something. You don't have a waiter standing in the kitchen going, is it ready yet? 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 Someone rings a bell. Okay, good modeling. And so it's a good restaurant. You leave from this good experience, 5-star, would eat again. So, what can we take from this? Chains of requests do not scale well. Yeah. Has anyone worked in a company where to get anything done you have to ask your manager, and they ask their manager, and then they ask kind of a sideways, and it goes down, and you're sitting there, and you're like, couldn't I have just gone and talked to them? Yeah. It doesn't scale. It's not a fun place to work. The chains of requests do not scale. It's not a way to get things done. People that have the information to do their job are a lot more effective at it. Again, these are kind of fairly commonly known things. But software boundaries that follow these same principles tend to work better. And a lot of it is around synchronicity. So, synchronous things where you're waiting for an answer don't scale and don't kind of work as well as things that are asynchronous. Again, ring the bell, the food's ready. So, applying this to services, if a service knows enough to do its job, then it's going to scale better, it's going to work better. So, I have a cute name for this, which is human-shaped microservices. Trademark. So, when I look at a software system and kind of try to bring it down to, well, if people were doing it, who would the people be? What would they be in charge of? How would they do that thing, and how would they communicate it? So, what would people do if we were building this system out of people? And again, synchronous chains of people asking a question, going, "What's the answer? What's the answer? What's the answer?" is not an effective business to be in. So you look at, well, if you were going to group this and have people doing those jobs, how would you organize that company to be effective? And then build the systems the same way. So a really good technique for this is something called event storming. Has anyone seen event storming? It's kind of a modeling technique where you get post-it notes on a board and you say, well, if we were doing this, I would tell the kitchen to make these things. And you go, okay, that's a command. And then the kitchen would say, this order is ready. That's an event. And you kind of, with different colored sticky notes, stick them all on a board with these are the commands and these are the events, and then figure out what talks to what and why. And you end up with a really good mapping of the way an organization should work, and then build the software around that. So again, commands and events work really well here. I'm going to quickly talk about kind of the tech of that, because often, people sort of tend to think about microservices as just REST. But I actually really like messaging for a lot of this stuff, because it maps really quite well. So HTTP is a synchronous transport, that's about requesting a document and getting something back. And what we've learned is synchronous calls reduce your reliability, and they reduce your ability to scale, and you have to deploy stuff at exactly the right time because there's not something there, it gets hard. So you can still use HTTP to model commands and events if you want, but it ends up being a bunch more work. You might have a table of events, and then all the other services have to kind of poll that table and keep a cursor, and it's extra database stuff. So messaging kind of works really, really well for this. For this style of thing, because you can put a command on a queue. Oh, sorry. And yeah, you can have pub sub, and messaging systems work really, really well for microservices. REST is still a great API service, particularly on the web. Like, the web is built around HTTP. We've got CDNs, we've got proxies, it's a really good protocol, and there's lots of semantics built into it, into HTTP, and then you sort of apply a REST style on top of that. That's a whole other discussion. Hypertext is a good thing. A lot of the web is built on that, and it scales really, really well. So I have a pattern that I've had a lot of success with that, again, as a joke one day, I called it mullet microservices, because it's got REST on the front and messaging in the back. And people seem to like that, so I'm sticking with it. But this is a pattern I've had a lot of success with, even in sort of replacing legacy systems, where you can build services behind a load balancer, but their backplane, the way they communicate to each other, is through messages, through a message broker, or something like that. And I'm running out of time, I'm going to be quickly. Some conclusions. from all of this is learn from history. Like if you want to set out to use a new technique or a new tool or a piece of infrastructure or a pattern or whatever it is, understand that idea and what led to it. Like what problem was being solved when somebody created this thing? What caused that problem that they were trying to solve? What caused that? And kind of understand the history of and context of how we got there. And doing that would just make you a better technologist. Like we're going to use this thing and it was designed to solve this problem. We have that problem. It's a good fit. If it's, we want to do that because it's on Hacker News and it's really cool, you're going to be a less effective technologist. Another takeaway is microservices and SOA kind of have the same roots and the same problems they're about. And if you can go back and read sort of the early stuff around SOA, it's about services that are loosely coupled and autonomously manage a business process. And microservices are kind of the same, but a bit smaller, but essentially the principles are there. And if we sort of don't autonomously manage that business process, they get super chatty. In modeling, look at the people, business processes, how would people do that, model your software after that. And then the main one is never forget that actually delivering value is the goal. That's what we're here for. That's the smart bit. Like your job isn't, well, I bring containers to an organization. Your job is about, delivering value, whether that's selling something to customers or solving an internal problem, whatever it is. That's the goal. And we get way too caught up in that. So yeah, with that, I'm going to do a quick plug, which is I'm teaching this stuff. And if anyone wants to come and talk to me about that, I would love to have that chat. Essentially, I've seen this enough times that I'm like, what can I do about this? So I actually want to teach it, teach this stuff and get hands-on, but I don't want to make it too much of a plug. With that, we're getting low on time. Any questions? And I'm happy for you to accost me all day and chat about this stuff, but any questions in the room? Yeah.
Thanks for that. That was great, mate. I work in a medium-sized organisation that's now integrating with a very large organisation. What are the kind of, I guess, cultural preconditions for microservices, and especially in an organisation that's already on the journey but potentially
risk-averse? Yeah, that's a tricky one, and honestly, I've not seen a one-size-fits-all to that. The biggest problem seems to be in those journeys and those organizations is that it's very hard to get anything started because they're so risk adverse that no one ever wants to fail. So it's, and I've seen this in a big organization where it's like, we want to do this thing, very simple, and they're like, you can't do that because we are still figuring out what our container strategy is or what our messaging strategy is, and then you've got a team of enterprise architects that will take 12 months to make a ruling on something before you can touch it, and it's all very and that's super hard. If you're in that organization and you can ship, then just do small things quickly. And again, in sort of technical stuff, HTTP is great. Like you don't want to expose, like if you've got, ActiveMQ or like a message broker back there, you probably don't want to expose that because you want to change your semantics. So if you go, well, this is our boundary is an API that people can request and treat it like a third party. Would love to hear more about it later. It's a tricky one.
Sorry, everyone. Damian's been called to the speaker photo now.
Oh.
So, we're going to have to.
Got to go get my
wrap it
photo
up.
took.
I'm sure, though, you can.
Yes, I'll be around.
Chase him down later.
Yeah, I'll be around all day. Yeah. Also, if you don't want to come and talk to me, Damian M on Twitter. If you'd like to tweet at me, happy to do it. Thank you, everyone, so much.